All right, so no new lesson notes today, so we're going to go right into the examples. After purchase, the value of a machine depreciates exponentially. Remember, depreciates means that the value of the machine goes down. So this is exponential decay. The table shows its value as a function of years since purchase. If a spreadsheet tool is available, consider using it to help you reason about the following questions. All right, so here's our value here. Find the decay factor of the value of the machine per year. Hint: to find the decay factor, divide any value by the value for the previous year. So that would mean I can divide 13,600 divided by 16,000, 11,560 divided by 13,600, so on and so forth. And notice what happens if I divide either of those. Whoops. Okay. If I divide that, I get 0.85. If I go the other route, 11,560 divided by 13,600, I get 0.85. If I go the other route and go 9,826 divided by 11,560, I get 0.85. The point is, to answer number one, the decay factor per year. The decay factor per year is 0.85. Number two, write an equation to represent the value of the machine as a function of time in years t. So we're going to use our exponential decay formula. Okay. So in this case, my initial value of the machine, my initial value is 16,000. So 16,000 is the initial value. We've already said my decay factor per year is 0.85. And I'm going to use the variable t here because they said to use as a function of time in years t. So I'm going to use the variable t. So this right here, okay, this right here is the equation that they're looking for. That is the answer to number two. The important thing to realize, as I've talked about before in past lessons, that t here is number of years. So that's the answer to number two. Number three, use the equation to find the value of the machine 6 months after purchase. So 6 months after purchase. 6 months after purchase. So in order to plug into that equation, I need to convert months to years. How do I do that? Well, I know that 12 months is 1 year, 24 months is 2 years, so on and so forth. So I have to divide the number of months by 12. So in order to do that, if I divide that by 12, 6 months divided by 12 is going to be equal to a half of a year. Okay, so 6 months is equal to a half of a year. So when I plug in to my equation that I figured out in number two, I'm going to not plug in 6. I'm going to plug in half, because 6 months is equal to a half of a year. So that's going to be 16,000 times 0.85 to the power of 1/2. Let's see what that ends up being. 16,000 times 0.85 to the power of a half. Okay. And because we're talking about the value of the machine in dollars and cents, we're going to round this to 2 decimal places. So this will be 14,000. $14,751 and 27 cents. Okay, so that is the value of the machine 6 months after purchase. Okay. Number 4, find the value of the machine 9 months after purchase. Okay, so we're going to do the same thing I did in number 3, 9 months. In order to convert that to years, I have to take that number of months and I have to divide that by 12. So 9 divided by 12 is 3/4. So that's going to be 3/4 of a year, or 0.75 years. So I'm going to do literally the exact same thing I did in number 3, but instead of plugging in 0.5 as my exponent, I'm going to plug in 0.75 as my exponent. Again, because 9 months is 3/4 or 0.75 years. So I can go to Desmos and I can replace that exponent. Okay, so this will be, let's see, $14,163.94. So that would be the value after 9 months. Okay, so that's the answer to number 4. Number 5, write an equation to represent the value of the machine as a function of time in m months. So m months, okay, I have to divide that by 12, just like I did with 6 months and m months. So the way that equation is going to look, if I take my original equation that was in years, okay, I can convert that to months by changing the exponent from t. Okay, by changing that, and let me get a fraction here, to m over 12. And let me zoom in so you can get a better view of that. Okay, if I change that to m over 12, where m now is now the number of months instead of number of years, I can now calculate it for any number of months. I would have been able to do number 3 and number 4. This way, 6 months, okay, that exponent would have been 6 divided by 12, which is a half. 9 months, the exponent would have been 9 divided by 12, which is 0.75 or 3/4. So this right here, that is the answer to number 5. Okay. Number 6, use that equation to find the decay factor per month. So in order to do that, all right, I'm going to play the same game that I did yesterday. If you watch the videos from yesterday's lesson, okay, so what I can do, I can take the equation, I can take particularly the exponent here, the m over 12, and I could break it down just like this here. playing that same game algebraically that I did yesterday, I can take this part of it and I can break down the m over 12. M over 12 is the same as 1/12 times m. If I multiply 1/12 times m, then I end up with m over 12. So these two are literally mean the same thing because 1/12 times m is equal to m over 12. And by rewriting it this way, I can now say without certainty that the decay factor per month, to answer the question, is not 0.85. It's going to be 0.85 to the power of 1/12. Whatever that value is, 0.85 to the power of 1/12, that is the decay factor per month.